So today we're going to cover rational exponents. And today we'll focus on negative exponents. Tomorrow we'll do the fraction exponents. So on the first slide is a screenshot from the textbook. So by definition, a negative exponent could be defined as taking that base that's raised to that power and moving it to the bottom of a fraction. So really what you should be thinking about when you see a negative exponent is think reciprocal. So, and let me show you how this all comes about. And that's sort of what they showed you up at the top. But I'll show you with maybe some fewer variables. So let's say I have x to the third power over x to the fourth power. So I could actually expand this out and get x times x times x over x times x times x times x, and then I can begin simplifying it. Notice what remains is going to be 1 over x. Now also what we could have done is apply our quotient property where we could take these exponents and we could subtract them. Because if you recall, when you divide, you're going to subtract 3 minus 4, and I get negative 1. So when it's x to the negative first power, notice what we just simplified this to is 1 over x. So whenever you see a negative exponent, it's going to turn it into a fraction. Or again, think reciprocal. So for example, if I have x to the negative 1 power, I could put a 1 under here to make it into a fraction and then turn it to its reciprocal and make the exponent positive. Same thing if it's a fraction. So if I had 2/3 and I was raising it to the negative second power, I'm going to flip the fraction to its reciprocal and make the exponent positive. And now do 3 squared and 2 squared and 9 over 4. If you also think about what this really means is when it's a negative exponent, it's like division. So let's say it's on the bottom this time. Let's say we have 1 over, and let's say this was the given problem. Again, if you think reciprocal, this is going to simplify to x to the first. However, the way that this is formed is if you take this, just like before with the complex fractions, this fraction bar means division. So what we're really doing here is 1 divided by, and then 1 over x, or x to the negative 1, is really this. And then if I do keep flip change, this is what I'm multiplying, and it's the same answer as if I just wrote the reciprocal. So just remember, if you have a negative exponent, if it's in the bottom and it's negative, move it to the top. If it's like a whole number or all by itself, not in a fraction, put it in the bottom of a fraction. Think reciprocal. And that's going to be the easiest way to deal with these negative exponents. Think reciprocal. So let's try some examples. So again, I have 3 to the negative 2 power. And again, if I think reciprocal here, I could put a 1 here, and then I can flip it and make the exponent positive. And then I'll evaluate 3 squared, and I get 1/9. Now, I'm going to show you the long way, and then I'm going to show you the short way. So the long way would mean to do this. As soon as you see a negative exponent, this means to take this whole thing and put it underneath the 1, and then make the exponent positive. And then again, remember what would happen here. So here, it would really mean 1 divided by 3 over 4 squared. So I could make it 1 divided by 9/16. Keep, change, flip, 1 over 1, 16 over 9, and then that's my answer. Now, if you would have just remembered that when you have a fraction raised to a negative power, flip it to the reciprocal, make the exponent positive, And now evaluate. 4/3 times 4/3 is 16/9. So you don't have to go through the long drawn out process of showing it's a division problem. Think reciprocal. Pretty good? Skip a slide here. Caution. Okay, biggest mistake I see is people see a negative exponent and they think it makes the answer negative. It does not make a negative expression. Think reciprocal. Soon as you see a negative exponent, think fraction flipped upside down. Think reciprocal. Okay, not a negative expression. So let's try some more. So we can also use the quotient rule. Now, for example, on this one, I'm going to show you a couple different ways to do this. Now, I can apply the quotient rule that they're talking about up here. Remember, when we divide powers that have the same base, all we need to do is take those exponents and subtract them. So I can actually do 5 minus 3, get 7 squared, and it's 49. You could also simplify it and write 7 5 times and 7 3 times in the denominator, and then go for things to simplify. So there's 2 left in the top. 7 squared is 49, and you get the same answer either way. If you're going to use the quotient rule, be very careful when you have negative numbers, because you got to do like a keep flip change or a stay change change. So be very careful. The other thing we need to talk about is anything to the 0 power. Remember, when we do the quotient rule here, I would be taking these powers of 4 and subtracting them. So if I do 5 to the 4 minus 4 power, I get 5 to the 0 power. And again, if you went back to the original problem, anything divided by itself equals 1. So you need to memorize that anything to the 0 power is 1. So if I ask you 1,000,000 to the 0 power, you need to know that it equals 1. Okay, and this is the whole reasoning behind it, is by showing it with this quotient rule. All right, so let's try some examples. Again, we're going to assume that all the variables are going to represent non-zero real numbers, because some of our examples here are going to have fractions in the denominator. And remember, whenever there's a 0 in the denominator, it makes the problem undefined. So we're assuming every variable represents real non-zero numbers. So again, a negative exponent does not make the problem negative. It turns it into a fraction. Think reciprocal here. So again, you could put a 1 there, flip it upside down, make it positive, and now we're going to evaluate 4 squared, which is 16.
Could we please have Gabrielle Ball to guide us at your convenience? Gabrielle Ball.
Okay.
Thank you.
You're welcome. Okay. All right, so for here, be very careful when you have a negative base. All right, let me just go over a couple of examples when the exponent is positive. So this problem right here and this problem right here give me two different answers. Okay, when the negative sign is in a parentheses, what this means is -4 times -4. Negative times a negative is a positive 16. However, this second example, the exponent is only on the 4. So then the negative sign will drop down, and then you do 4 squared, which is 16. So the difference is when there's parentheses, it turns positive. No parentheses, it's negative. So be very careful. So let's look at this one when the exponent is negative. Again, what this means is this -2 is only on the 4. So what I can do is move it to the bottom, make it positive. This negative sign would stay up top, and I would put it as a -1. So this would become 1 over, or -1/16. So be very careful with negative bases, whether it's a positive exponent or a negative. The next one. Now we're going to just basically be simplifying or rearranging our problem. So when we have a negative exponent, remember it moves it to the bottom of the fraction if it's in the top. But if it's negative in the bottom, it goes to the top. So we're just rearranging here. So on this example, the only thing that has the negative 3 exponent is the letter y. The x doesn't have the negative 3. So when I go to simplify this, the x is going to stay on the top of the fraction, and the y to the third is what will move to the bottom. The next problem I can do several different ways. First of all, I could just simplify. So I could take 4x to the third, 16x to the fourth. I could reduce the 4/16 and make this 1/4. And then for the x's, I could just simplify it. Take these 3 away and leave 1 in the denominator. I can simplify it that way. Or I could have also simplified. Let me write it again. Another way to do it is simplify the 4/16 and then take the x's that have the same base and do 3 minus 4, and then this would become x to the negative 1. Again, remember when you have a negative exponent, you write it in the bottom. So you can do it either way when it's asking you to simplify something like this. Just know that positive exponents stay where they are. The negative exponents are the ones that are moving. Let's try another example. In this example, the only thing that has the negative 2 power is the x. The 3 is going to stay on top, and the x squared moves to the bottom. On example 7, only things I'm moving are the negative exponents. So I'm going to move this one, the x to the negative 3, and the z to the negative 3. The 4 and the y squared are going to stay on top. Then the negative exponents will move to the bottom. So x to the third at the bottom and z to the third on the bottom. So if it has a negative exponent, move it. Now this next one, the ones that I'm going to move are the x squared, the x to the negative 2 power, and the y to the negative 3 power. Everything else is going to stay where it is. So I have a 3, I have a y to the 4th, and I have an x to the 4th that are staying. I'm going to move the green x squared to the bottom, and the blue y to the negative 3 to the top. Now, remember when you multiply exponents, you add them. So I'm going to combine my y's and combine my x's. So this would become 3y to the 7th over x to the 6th. You take the powers and add them when you multiply. Now, we could have also used the quotient rule here. So we could have also instead, let me rewrite it, look for the letters that are the same. So for example, here are my x's. For the quotient rule to apply, remember you subtract exponents. So if I were to take negative 2 minus 4, I would be getting x to the negative 6 power. When it has a negative exponent, remember, you write it in the bottom. Look where my x ended up. Then for the y's, I could have taken 4, and be careful here, minus negative 3. And you get positive 7. And that's why the y ended up in the top. So if you're going to subtract the exponents and you get a positive answer, you write it in the top. If you get a negative exponent, write it in the bottom. You can use either technique. The problem with doing this, you must be very careful when you have a lot of negative numbers, because that can mess you up. Good so far? All right, let's try another example. We have the same base, so I can do this two ways. I can take my shortcut here and just do 5 to the 9 minus 7, get 5 squared, 25. I could also just simplify. I could take 7 out of this one and leave 2 behind, or I could write out 5 9 times. 4, 5, 6, 7, 8, 9. 1, 2, 3. And then write 7 on the bottom. And then look for things to cancel. And then however many don't cross off. And there's 2 left, so 25. However you want to tackle these. Okay, again, same thing with the x's. I could write out 14 x's and 10 on the bottom. For these, it might be a lot easier just to do 14 minus 10, and it's x to the 4th. Or again, take out 10 and leave 4 behind. Either way. Here where the top is smaller than the bottom, again, if you subtract, notice you're getting a negative 4, so this would be y to the negative 4, which tells you that it's 1 over y to the 4th. Again, you could write out 8 y's on the top, 12 y's on the bottom, and cancel them, and you would see that there would be 4 left in the denominator. Here, where, oops, I missed another one with base of 7 here. So again, I could do 7 to the 5 minus negative 3, which would give 7 to the 8th, or take this negative exponent, move it to the top, and then it becomes 7 to the 5th, this guy that moves to the top now, and again, when you multiply, you add the exponents. Either way. For this one, again, I could rearrange, move this guy to the bottom, this guy to the top, or I could even subtract negative 4 minus negative 8, and you're going to get positive 4. So that's what the x power is, but let's go ahead and simplify this. So 15 over 5. And then now I can simplify my x's. So if I move the x to the 8th to the top and the x to the 4th to the bottom, simplify, and there's 4 left. So 3x to the 4th. Notice when I subtracted it, my power was positive. So that's why it's not in a fraction anymore. Again, we can either subtract the a's powers and the b's powers, or I could just move things around. So I would move the negative 5, a to the negative 5 power below, move the a to the negative 2 up, move the b to the negative 1 down. The b to the 4th is positive, it's staying where it is. So again, 15 over 25 is going to simplify to 3/5. So now if I put a to the 5 in the bottom, a squared in the top, b to the 1st, and b to the 4th. So now I need to simplify this some more. So now I could do this, take care of my b's first, and get b to the 5th. And now I got to take care of the a's. So I could cancel this and leave 3 behind. So this will be 3/5, a to the 3rd, b to the 5th. Or we could have subtracted the exponents. Either way. The next examples are just going to be a review of what I did back in, I think, R3, okay, where we're going to be multiplying some monomials. So this is just dealing with the negative exponents. Again, your goal is to get the exponents always to be positive. So again, to change a negative exponent to make it positive, move its location. If it's negative in the top, move it to the bottom to make it positive. If it's negative in the bottom, move it to the top. So I practice of everything, even the stuff we did back from R3. So when I'm multiplying two monomials, remember you multiply the coefficients. So 5 times 2 is 10. And then for the powers that have the same base, I'm going to add their exponents. So 2 plus 3 is 10. For 16, again, multiply the coefficients. So I'm going to multiply 2 over 1 times 2 over 3, and I'll get 4/3. And then I'm going to go back and add up my x's. So I have an x squared and an x to the first. So that becomes x to the third. And then I have a y to the first and a y squared, and that's y cubed. 1 plus 2 is 3. Don't forget that these variables that don't have numbers, assume there's a 1 there. Then 17, I'm going to multiply the coefficients. So 3 times 1/6 times 8. So 3 over 1 times 1/6 times 8 over 1. I'm going to simplify diagonally and get 4. Go back and add all your x's. I've got 3 plus 2 plus 1 gives me x to the 6th. Pretty good so far. Yep, I missed one. Okay, so again, when the bases are the same and you're multiplying, remember you just add the powers. So you keep the base, you don't multiply 3 times 3, and then q plus p. If you want to write it in alphabetical order, again, you could apply your commutative property. Either way. So remember, when you're multiplying, we do not multiply the base. You keep the base, but add the exponents. Same thing on 19. Keep the x, add the 2 plus n. If you'd rather write it as n plus 2, that is perfectly fine. And again, power to a power, you multiply them. And again, anytime you blank out and forget what this means, remember, you could take x squared, write it 5 times, and then you could even expand x squared and write x, x, each one, x, x. And then when all is said and done, go back and count how many x's you just wrote down. And there should be 10 of them. So again, think about it logically if need be. But simplest way, power to a power, you'll multiply them. All right, did I miss? This next one, again, remember this power distributes to the 2 and to the x squared. So this exponent of 4 will go on the 2, the power to the power, this becomes x to the 8th, 2 to the 4th power is 16, x to the 8th. The next one, this power is going to go to each thing. So 3 times 3 is 9 on both of the powers. And again, when the exponent is odd, your answer is negative. If that exponent would have been even, it would have been positive. 23. Again, multiply your coefficients. Oh, wait, time out. We need to evaluate the power first. So I need to take care of this exponent of 3. Needs to go to all of the pieces first. I need to follow PEMDAS. So 3 cubed, a squared to the 3rd power is a to the 6th, and then b to the 3rd. I'm going to figure out what 3 to the 3rd is. It's 27. Now I can go back, multiply my coefficients, and add my like exponent bases. So 27 times 2 is 54, going to go back and find the same base. So I've got a base of a with a power of 6, base a power of 3. So I would add that, 6 plus 3, and I would get a to the 9th. Go back, do the same thing with the b's. Again, on this last one, assume that there is a 1 here. So 3 plus 1 is b to the 4th. And one last example. Again, power to a power. So I'm going to multiply a to the xy power. Now on this one, I could write it as yx, but again, I like to write things alphabetically so I can see that those are like those are like terms. So again, same base, add these exponents. So 1xy plus 1xy gives me a to the 2xy. So be careful on those. So that is your quick review of rational exponents, most specifically negative exponents, and tomorrow will be the fraction exponents. Still rational, but they'll all be fractions. And we're going to turn those into roots. So your homework is R.6a, and it's 3 through 35 odd. And that is it.